Hello, today we're going to talk about Newton's second law of motion. The second law of motion is force equals mass times acceleration. And remember, mass is the amount of stuff inside an object. That's not the scientific definition, but think of how much is packed into something. For instance, a baseball has more mass than a volleyball because the baseball is packed solid, where the volleyball has a lot of air. So the baseball has more mass than a volleyball. Now the equation for this is force equals mass times acceleration. What is acceleration? Well, it's a measurement of how quickly an object is changing speed. Think about driving a car. You hit the accelerator, the pedal that makes you go faster, or you lift up on the accelerator, which makes it go slower. So the accelerator on a car changes your speed. It makes you go faster, or it makes you go slower. So that's the same thing. Acceleration is how quickly an object is changing speed. So acceleration isn't exactly the same thing as the accelerator on your car, because if you're driving and you want to go 80 miles an hour, you don't just hit the accelerator and boom, you're going 80 miles an hour. It takes time to get up to that speed. So the amount of time it takes to get up to that speed is acceleration. When you take your foot off the brake, the amount of time it takes to slow down to maybe 20 miles an hour, that's acceleration. Now let's take a look at the next slide. What does F equal ma actually mean? Well, force is directly proportional to mass and acceleration. They have a relationship with each other. So imagine you have a ball and it's a certain mass and it's moving at a certain acceleration. This ball has a certain force. Now, let's take this same ball, but let's make it twice as big. That means the mass has doubled. But the acceleration is still the same. It stayed constant. Force equals mass times acceleration says this new ball that's twice the size also has twice the force as the old ball. Because we increased its mass, we've also increased its force. Now, imagine the same original ball. It's moving twice the original acceleration. Force equals mass times acceleration says that the ball will again have twice the force of the ball at the original acceleration. Why? Because the acceleration has doubled. So anytime you increase the mass or the acceleration, you also increase the force. So now let's look at our third picture here. What does force equal ma say? So we're going to put this down to our notes if you are taking notes. And force equals mass times acceleration. Basically what that means is that the force of an object comes from its mass and acceleration. So how much force does something have? Well, if we want to know how much force something has, we just need to know two things. How much mass does it have? And we need to know its acceleration. If you double the mass, you double the force. If you double the acceleration, you double the force. Doubling the mass and the acceleration quadruples the force. So let's think about that. If you double the mass, that's 2 times bigger. And you double the acceleration, that's 2 times bigger. 2 times 2 is 4. So it's 4 times more force. We just plug that in. 2 times mass, because we doubled the mass, 2 times acceleration, because we doubled the acceleration, equals F4F. We quadrupled the force. So, what if you decrease the mass by half? How much force would the object have now if we actually decreased it? So, let's say we have something very massive, high mass, that's changing speed very slowly, low acceleration, like a glacier, can still have a great force. Something very small, low mass, that changes speed very quickly, high acceleration, like a bullet, can still have a great force. Something very small changing speed very slowly will have a very weak force. So let's think about a huge glacier. A huge glacier is not going to move quickly. It's going to move very slowly. But it's still going to have a great force because the mass is so big. So even though the acceleration is small, it's still going to have a great force because of how big it is. Now let's look at that second example, a bullet. Well, we know that a bullet has very low mass. There's not much in there, not much to it. But its acceleration is so high that it creates a very great force. So without that acceleration, the bullet really wouldn't do anything. It needs that high acceleration in order to create that great force. So this is our second law of motion. If you have any questions, please email me or hit me up on chat. And I hope you have a great day.